Hi grade 12s. This is our next lesson on grade 12 financial math. So it's still under topic 2 because it's a type of annuity, but this is topic 2.2 because we're now doing present value annuities, which is just the next type of annuity. So let's have a look. An annuity, don't forget, is a regular and fixed payment. So far we've done future value annuities because we were trying to build up a lump sum of money in the future. And so our examples were something like pension funds or retirement annuities or savings. Now, a present value annuity is where your lump sum is in the present. So it's fairly simple to figure out which one's which because you simply, as I've said before, ask yourself, where is the lump sum of money? Now, why would there be a lump sum of money in the present? And why would you then make regular fixed payments? If there was a lump sum of money in the present, if you're making regular fixed payments, you are trying to pay this lump sum off. And so these examples are things like home loans, where there is a lump sum of money that you own now, and every single month you pay a fixed amount in order to amortize, which means to pay off the loan. So basically this is pretty much generally restricted to loans because that's the type of thing where there's a lump sum now that you're slowly decreasing. Now, I said here you have to pay this off, for example, home loans. It doesn't have to be a loan. So it could be a lump sum in the present that you're slowly decreasing. Now, what would be an example of this? Well, we're going to be doing an example exactly like this, where if you've saved up for retirement and then you go on retirement, what happens is you generally then retire with a lump sum of money. And you can arrange your finances so that you get a monthly payment from this lump sum as a kind of like salary. And so slowly but surely you'd be decreasing that lump sum of your retirement package. And so we will do an example of like that. Now mostly we use examples of loans, but it doesn't have to be a loan, and so just be aware of that. Okay, now we're going to jump straight into deriving the formula, which is a little bit more tricky than the future value annuity. So if you take out a loan of P Rand, now I'm using a loan, but it could be a lump sum that, as I say, you're withdrawing fixed payments from every month as a kind of salary. So let's say you take a loan of P Rand. So that is the lump sum that you have now. Now, if you are going to repay this in equal monthly installments, starting 1 month after the loan is taken out, what is going to happen? Okay, so let's have a look. If I have X Rand, and I'm paying X Rand every single time period. Now this particular question said monthly. It doesn't matter whether it's monthly or annually. Every single month or every single year, I'm paying X Rand, blah, 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 blah. And eventually, you will have your last payment and you would have paid off your loan. Or you would have reduced all your savings. Okay, so let's have a look at this. If you think about it, this loan has to equal all the payments that you've paid off. Simply because if you've paid off your loan, whatever your loan is, surely it must be the sum of all the money you've paid off. Now the only problem is you can't just say, cool, I paid off X, I don't know, N times. Because remember, you cannot add money together unless you know what it's worth at the same time. So let us look at where this loan is. This loan amount is here in the present. It's right now. So can I find out what this X value is worth now? And can I find out then what this second payment of X is worth now? Can I find out what this third payment of X is worth now? So basically every single one of these payments, can I find out what they're worth now and add them all together? And if I can do that, my loan will be all of these X values, what they're worth now, added together. So basically I need to I always call it move my money. I need to find out what each of those X values will be worth in the present. So I'm going to erase my lovely colorful arrows for a second just so I can work with my timeline. Let's pretend that we made N payments. So let's pretend that this is the nth payment. And let's start with that last payment. Now, if you think about it, this X is kind of the future value of what it's worth now. I want to say, what is that X value worth there? So I want to bring it all the way back. So this X is what, I don't know, I'm going to put a little question mark. That's what the question mark is, what it's worth now. And I would have added on interest for n time periods. That question mark would have been in this account, if you think of it like that, for n time periods. And so how do I find out what that X is worth now? I actually have to divide by 1 plus I to the power of n, and that's what it is worth now. Now, how do I write this in a manner which is going to suit me? If I bring that entire fraction to the top, that entire denominator to the top, I can make it a negative exponent. So if I color coordinate that, that X is worth X, 1 plus I to the negative n in the beginning. So basically I've kind of undone all the interest that would have been added to get to a value of X. Now if you have a look at this X value, I want to take that X value all the way back to the beginning and say, what is it worth now? So that X value will have surely one less time periods worth of interest. So it wasn't in the account for n time periods, it was one less. Now why have I said negative n plus 1? Because if I go and doctor my formula down here, this would have been this would have been n minus 1 if I doctor my formula over here, because it would be 1 less than n. So when I bring it to the top, this actually becomes plus 1. So remember, negative n would be, I don't know, like negative 20 if it was 20 payments. Now I want this guy to be negative 19, so I'm actually adding 1. And I can continue. So this X, if I try and find out what it's worth now, it will be X, and I have to undo interest for n plus 2 time periods, negative n plus 2. Again, because it's the same idea. If it's a negative exponent, I now want to add 2 to make it that exponent less than what it was, although it's negative. Okay, so hopefully this is making a little bit of sense. Now I'm just going to raise this to create a bit more space for myself, because basically what I would do is I would continue this pattern. Let me raise, and I would continue this pattern, and I'd say plus blah 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 plus, and all the way down to this very first X that you would have paid off. Now notice the first X you paid off is not in the present. And that's because if I was going to pay something off on my loan right now, I would just take less of a loan. It would be a deposit. It wouldn't be part of the loan. So your first payment is paid one time period later. So this X value simply needs to have its interest undone for one time period. Now that's going to be really important in a moment when we discuss the kind of conditions under which this formula works. Your first payment is made one time period after you granted the loan. Now if you have a look at this, what I'm arguing is if I add all of these payments together, what they're worth now, I will get what my loan is worth now. Now the question is, how do we do this? Well, this is a geometric series, exactly like the future value annuity. So I want to find out the sum. What is my A value? My A value is X, 1 plus I to the negative n. That's the first term over there. What is my R? Well, to go from that term to the second term, I have multiplied by my bracket of 1 plus I, because I've added 1 to the exponent. And then I've added 1 to this exponent. So to go from my second term to the third term, I've multiplied by 1 plus I. So my R, exactly in the same as my future value annuity, is 1 plus I. And if I say I'm making n payments, I can now use my geometric series formula to create a formula for my present value annuity. So what was the formula for Sn? Sn is A, R to the n minus 1, all over R minus 1. So my A is X, 1 plus I to the negative n. R is 1 plus I, and it's raised to the power of n, minus 1 all over 1 plus I minus 1. Now we just want to neaten that up a bit. So how we're going to neaten it up is we're going to keep the x outside just because it's a little bit easier, and I'm going to multiply this bracket into the big bracket. So if I multiply, when you multiply powers of the same base, you add exponents. So this is 1 plus I in a bracket, and this is 1 plus I in the bracket, so my base is the same. So I'm going to add these exponents together. So I'm basically going to get the fact that I have 1 plus I as my base, and it's negative n plus n. And multiply that entire bracket by minus 1, and it's 1 plus I to the negative n. Now at the bottom, 1 plus I minus 1 is just I. Now finally, I'm hoping that we realize that negative n plus n is 0, and anything to the power of 0 is 1. So it actually becomes 1 minus 1 plus I to the negative n all over I. And you'll notice it is very similar to the future value annuity formula. It's just the kind of the first bracket's almost swapped around and with a negative exponent. And this is what we call a present value annuity formula. A little bit more tricky to derive that, simply because of the idea of bringing the value of those x's back. Now let's just quickly discuss what's what in this formula. P is the lump sum in the present. Now that could be a loan, it could be an investment that you are now going to decrease in value every month because you're going to get a payment from it. X is your monthly either payment if it's a loan, or it's your withdrawal if this was an investment that you are gaining money from. So I'm going to say monthly installment. Either you're paying for the loan or you're receiving this monthly installment. I is your interest rate, and N stands for how many payments. So how many payments are either made to you, or how many payments are either made to pay off the loan. So how many payments are made. So N doesn't stand for time period, it stands for number of payments. And I is obviously our interest rate. So very, very similar to the future value annuity formula. Now the only kind of T and C that applies here that's really, really important. If I look at how I derived this formula, the kind of premise that this formula works on was the fact that here is your loan in the beginning, and one time period later you made a payment. Now that's how we derive this formula. So if there's any other situation that doesn't fit that, I can't just automatically use the formula. So I'm just going to write myself a note here, and we will do an example which kind of plays on this idea. Built into this formula is the idea that one time period's interest is added, and then your first payment is made. So let me write that down. Built into this formula is the idea that one time period, now I say time period because you could be paying monthly, you could be paying quarterly, you could be paying annually, so it depends. So one time period passes, and then the first payment is made. Either paid to you or obviously paid by you. So again, we'll come back to this idea, and it might make more sense when we get there. So built into this formula is that one time period of interest is added, basically. So let me say this. So therefore, one time period of interest is added. And then your first payment is made. So we'll come back to that idea in a moment. Okay, so let's look at a couple of examples to make sure we can use this formula. So it says a loan is taken out, which immediately makes me think, not future value annuity. It's repaid with, there we go, equal quarterly payments. Don't forget that you've got to look for that regular fixed payment to make this an annuity. So this is an annuity because there's regular payments and it's a present value annuity. So I immediately write down my formula. It's on your formula sheet, so please don't make silly mistakes and write it down incorrectly. Right, let's have a look at what we know here. A loan is taken out. It's repaid over 5 years with equal quarterly payments of 2450. Interest rate is 8%, so 0.08. compounded quarterly. Now that's very important. You can't make quarterly payments if your interest isn't compounded quarterly. So that's very good. And number of payments, well, it's 5 years. And how many quarters in a year? There's 4. So there are 20 payments. Remember, N doesn't stand for time period, it stands for number of payments. And the question says, if interest is charged at that, what is the loan? So I'm basically solving for P here, which makes it basically a substitution. Pick up your calculator question. So 1 plus 8%, compounded quarterly, 20 payments, all over my interest rate. So let's plug in our calculator. Now I really should check this, but I get 40,061 Rand and 1 cent. Right, so that was easy. Let's look at the next one. A house cost 1.8 million. Calculate the monthly repayments. So I'm definitely thinking not future value. If the interest is added at 14% per annum compounded monthly. Okay, so monthly repayments makes this an annuity. It's not a lump sum. And it's definitely a present value annuity because the lump sum is in the present. I'm not trying to build it up in the future. So my formula, my cost now, my lump sum now is 1.8 million. I'm trying to calculate X. My interest is 14% compounded monthly, so divided by 12. I am making 20 years worth of payments, but it's a monthly payment. So that is minus 240 is 20 years, all divided by my interest rate. Now exactly the same as a future value annuity is I work this out on my calculator because that's the coefficient of X, and I basically take 1.8 million and divide by that. So I got an X value of 22,383 Rand and 37 cents. Now, this is pretty cool because this is exactly what you at some stage in life might be doing. Buying a house, 1.8 million is a fairly sizable amount, but that's pretty much what you'll expect to pay for a decent house in a nice area. And monthly repayments, 14% is a bit high. The current repo rate they've just dropped it, but I think it's about 9%, but it's generally averaging about 10% in the last couple of years. So that interest rate is a bit high. But basically it means you can expect to pay 22,000 Rand a month on your home loan. So these are the type of calculations that you'll be working with when you're trying to think about buying a house one day. Right, let's look at the next example. Example 4. Sorry, let me scroll down. Shirley buys a car at a cost of 340,000 Rand. She's required to pay a 10% deposit. Okay, that often happens. They need to secure some money from you. Then the balance is paid off in equal monthly repayments. So this is a present value annuity after you've paid the deposit. Interest is 9% per annum compounded monthly. Determine her monthly repayments. So first of all, I need to work out my deposit. My deposit is 340,000 Rand, but 10% of that, which is 34,000 Rand. So my loan that I'm taking is not actually 340,000 Rand. It's 340,000 Rand less the deposit because you've paid some of the vehicle off, which gives me 306,000 Rand as my loan. And now it's a standard present value annuity calculation. So I'm going to go straight to substitution. You don't have to show the formula. X1 minus 9%, so it's 0.09 compounded monthly, and you're paying it off over 5 years. So it's negative 60 because it's monthly repayments. So 12 times 5, 9% compounded monthly. Again, I would work this out as the coefficient of X and then just divide by it on both sides. And I get a monthly repayment of 6,352 Rand and 6 cents. Right, let's see what the second part says. The second part says, how much did she actually pay for the car after 5 years? Now, she doesn't end up paying 340,000 Rand for her car because built into all of those repayments is interest. So what did she actually pay? Well, first of all, she paid her deposit. Her deposit was 34,000 Rand and she paid for that before she even took the car. Then she made 60 monthly payments of 6,352 Rand and 6 cents. Now that gives me the fact that she has paid 415,123 rand and 60 cents. Now, of course, that's more than 340 because of the interest, and obviously the difference between that and 340,000, so 75 odd thousand rand, that's the total interest that she paid over her 5 years. Okay, let's have a look at Celli. She pays 2,200 rand into a pension fund every month, so I see every month. So I'm thinking annuity for 30 years until she retires at 65. Now, that doesn't sound like a present value annuity at all because she's saving towards a lump sum in the future. So this is a future value annuity. The pension fund earns interest at 13% per annum compounded monthly. How much money is in her pension fund on the day she makes her last payment? Now, on the day she makes her last payment is essential because that's the kind of T's and C's for the future value annuity formula. The future value annuity formula, which we hopefully remember, but it's on our formula sheet, has built into it that it works out the amount of money you have on the last day you make your payment. So she pays 2,200 rand into her account. She's getting interest at 13% compounded monthly. She pays for 30 years, so that's 30 times 12, which is 360, minus 1, all over her interest rate. Okay, so she earns a sizable amount of money. She earns 9,621,193 rand and 52 cents. Again, that is the power of compound interest. So, on the day she makes the last payment, she's got 9.5 odd million. Now it says, on the day she makes her last payment, she transfers the money into a savings account and makes monthly withdrawals for her retirement, which is pretty much one of the models you can use for retirement. So this is the example of where this is a present value annuity, but it's not a loan. So there's a lump sum for her in the present. So in her retirement, there's a lump sum on the day she retires. 1 month after she transferred the money, she started making withdrawals. Now that's exactly what this formula does. This formula takes the money and adds it interest for one time period, which in this case is 1 month, and then starts making withdrawals. So there's nothing funny about that. That's exactly how this formula works. That's perfect. So on the last day she makes a payment, she transfers. She gets 1 month worth of interest, which is built into this formula, and then she starts making withdrawals, and she hopes to withdraw money for 20 more years. And she wants to leave no money left in her account for her greedy little children. So if interest is earned at 15% per annum compounded monthly, what are her monthly withdrawals? So what can she afford? So this is a present value annuity. It's a good example of one where it's not a loan, because otherwise we always think it has to be a loan. So she has 9,621,193 rand and 52 cents. I don't know how much she wants to withdraw. Interest is 15% compounded monthly, which is incredibly high. That's not particularly realistic. She wants to make withdrawals for 20 years, but monthly, so that's 240 withdrawals divided by my interest rate. So we've done this before. I'm going to work out this coefficient of x and then divide by it. And I work out that she can therefore afford to withdraw 126,690 rand and 87 cents, which sounds like a hell of a lot of money, but you must remember, in 30 years' time, 126,000 is not worth 126,000 like it is now, because your money, everything inflates, and so it would be interesting to see how much is 126,000 in today's kind of money terms, to see how big that is, because that sounds huge now, but in 30 years' time, who knows what 126,000 rand will buy you. That's called buying power. How much money can actually buy you, what it actually means is called its buying power, which is fascinating. Great, so that was a nice example of using both annuities. Right, our last question, still on Celli. Celli buys a new car for 150,000 rand, and she agrees to pay the car off in equal monthly installments starting in 6 months' time. Okay, so this is sounding like a present value annuity because it's a loan, equal monthly payments, but starting in 6 months' time is a problem. Now, this is exactly what car companies do. You'll often hear adverts in December where they say, buy a new car now, but only start paying in March 2021 or whatever. And it sounds wonderful because you're like, oh great, I don't have to pay for a while. But what happens when you have a loan ever? Your loan just doesn't stay stationary. It increases in value due to compound interest, and compound interest is dangerous. So make no mistake, they're not being nice to you. They will be adding interest for that time that you're not paying them, which means you actually end up paying more. So the sooner you can pay something off, the better. So if I have a look at this, Sally owes 150,000 Rand now. So that's her present value for her loan. She starts paying off in 6 months' time. So in T6, she starts paying X. And then she pays 31 payments. 31 payments. Which actually means at the end of time period 36, she will make her last payments. Now it's not 31 plus 6 is 37 because she paid in the 6th month. So her first payment was in the 6th month. Now that doesn't really matter because they've told us there's 31 payments. So what happens in month 1? Nothing. Month 2, 3, 4, and 5. Now I'm drawing this picture because I want to show you that the way the present value annuity formula works is you need to know what the loan is one time period before you start paying, because this part of the timeline is your present value annuity formula. It works on, it automatically adds 1 month worth of interest and then makes your first withdrawal. So 150,000 Rand, which is now, is not what I can use in my present value annuity formula. So what do I need to do? Well, there's 1, 2, 3, 4, there's 5 months where nothing is happening except your 150,000 Rand is gaining interest, which is not ideal. So Sally is being silly. So for 5 months, I just need to add on compound interest. Now, not 6 months, which is quite tempting because she only pays in 6 months' time, because there is 6 months worth of interest added, but the formula, the annuity formula, automatically adds on an extra month for you. So 5 months you have to add yourself, then the formula will add the 6th month and then start paying. So I've worked out that she owes 155,710 Rand. Now I'm going to keep all my senses because this isn't the answer to the question. Now that's the amount that I can use in my present value annuity, because that's the amount my loan is there. So now I can use my present value annuity formula. I'm going to go straight to substitution. So she owes a loan of 155,710 Rand. I don't know how much she's paying. Her interest is at 9% compounded monthly, and they've told me she makes 31 payments. They could have made this question a little bit more difficult and said her last payment is at the end of 36 months. And then most people will take 6 away and say she makes 30 payments. So just be careful. How many payments did she miss? She missed 1, 2, 3, 4, 5 payments. She hasn't actually missed 6 payments, which is why I know that it's 36 months when she ends. Right. Now, once again, we've done this before. This number here is just the coefficient of x. So I'm going to work it out and divide by it on both sides. So I get that she must make monthly payments of 5,648 Rand and 15 cents. Okay, so that one was trying to show you the built-in idea of the interest. Right, so we've done enough practicing. I'm quickly going to write a summary like I did for the future value annuity. First of all, the thing we need to know is the formula that we have derived. So I've written 2 things down there. First of all, I've written the formula. You do not have to know how to derive any of these financial maths formulas. I've also written there that how do I know it's a present value annuity? Because there's a lump sum in the present and you're slowly decreasing that lump sum for whatever reason. Okay, what's the second thing we learned? We learned that the T's and C's for this formula is this formula automatically adds on 1 time period interest and then withdraws the first X. So I've just written that concept down. And so we just need to remember how the formula works so that we can manipulate the needs if the formula doesn't fit our situation, just as it didn't do with Sally. And that's pretty much our summary for present value annuities, which is the end of topic 2, because there are only 2 annuities. And so now we're going to start working a little bit more with them to find out what else we can calculate using them. Well done, guys.